We will see how quadrature phase shift keying method works. Incoming bits pass through a serial to parallel conversion. So here, serial bits are converted into parallel bits. Then one bit is sent to the one modulator, and next bit is sent to another modulator. So means here serial bits are converted into what? Parallel bits. So one bit, the first bit is sent to one binary phase shifting method, that is in phase, and the second bit is sent to another modulator, means so out of phase. So second bit is sent to another binary phase shifting modulator. So the phase value for that is what? Out of phase. So that is called quadrature. It's called quadrature. Now we'll see how to send the serial bits to what? Two modulators. One is in phase, another one is out of phase. So two composite signals for modulators are then added. Here, this will produce one composite signal. Then this will produce another signal. So these two signals are combined here to generate what? Another composite signal. So totally here we will use what? Four phase values. Four phase values. We'll see how to use those four phase values. The two phase values in phase and another two phase values for out of phase. So diagram shows quadrature phase shift keying method, its implementation. So now consider we are sending two bits at a time. Two bits at a time. So network is slow. If facing any problem, you can type in short option. I think my voice is audible, right? It's okay. So here we are sending two bits at a time. So consider one example 0 0 1 0 0 1 1 1. So this is what serial data 0 0 1 0 0 1 1 1 serial data. We need to convert serial data into parallel data. Then after converting serial data into parallel data, one bit is sent to one modulator, another bit is sent to another modulator. So one modulator is in phase, another modulator is in out of phase. Now we'll see how to send these bits to modulators. So quadrature means we are using four phase values. So 0 0 1 0 0 1 1 1, two bits at a time. Two bits at a time. See here, first bit, take first bit, for that generate digital signal. First bit is 0, so 0 means negative voltage. Second bit, take second bit here, so 0 negative voltage. Next consider next two bits, 1 0, first bit. Here first collect first bits from what? Every two bits. So for that generate digital signal. Can use any line coding technique to generate digital signal. 0 1 first bit. Here 0 is the first bit, so negative voltage. 1 positive voltage. So red color indicates what? The first bits of every two bits. So for that generate digital signal. That is the first step. Next to take the second bits of every two bits. 0 0 1 1. So for those bits also generate digital signal. So 0 0 1 1, negative negative, positive positive. So this is a digital signal for 0 0 1 1. After that, so use uh, oscillator, then generate carrier signal. Use oscillator, generate carrier signal. So here the carrier signal frequency is what? So 1, 2, 3 cycles per second. 3 cycles per second. So here we are using 3 cycles per second and phase value is 0. Phase value 0. So next here consider the phase value 90. Phase value 90. Here 1, 2, 2.5 cycles. So for second bits we are using 2.5 cycles to represent digital data. Here 3 cycles, here 2.5 cycles. So phase value 0 for what? Carrier signal. Here phase value 90. So by using carrier signal and digital signal, we need to generate analog signal. Analog signal. The bit is 0. The bit is 0. So phase value 180. The bit is 1. Phase value 0. So like that, we have to generate analog signal for the given digital signal. So 0, 0 means start signal from phase value 180. 1 means start signal from phase value 0. So here we are using two phase values. One is 0, another one is 180 for first bits in the sequence. For first bits in the sequence. So here 180 means phase value 180 means indicates bit 0. Phase value 0 means indicates bit 1. So by using this concept, generate analog signal for the first bits of every 2 bits. Next, after that, take the second bits of every 2 bits. So for this sequence also, we have to generate analog signal. So here 0 means 270. The base value 270. 0 means 270. 1 means the base value 90. Base value 90. Here also 90. So 1 means 90. 0 means 270. So totally we are using what? 4 phases. One is 0. Another one is 180. One more is 90. Another one is what? 270. We are using 4 phase values. 4 phase values. Using what? 4 phase values to represent digital data. So therefore it is called what? Quadrature phase shift keying. So phase values we are shifting the based on digital data. Phase values varying for every bit. So therefore it is called what? Quadrature phase shift keying method. So after generating signal for what? The first bits of every 2 bits, then second bits of every 2 bits, and we need to combine these two. We need to combine these two. So we will get final analog signal. This is the final analog signal. Final analog signal. So this one is done by what? The summation, adding. We need to add this signal with this signal. If you add this signal with this signal, we will get this signal. Here the phase value minus 135 minus 45, here 135 45. The phase values in varies. Phase values varies. Now we will see the hardware representation. Hardware representation for quadrature phase shift keying method. This is what the signal representation. Now we'll see hardware implementation or hardware representation. First, we have to convert serial data into parallel data. To convert serial data into parallel data, we need to take 2 bits at a time. 2 bits at a time. So therefore, to take 2 bits at a time, we have to use one hardware called 2/1 converter. Means it will take 2 serial data means 2 bits at a time. Then it will generate 2 parallel bits. One is sent to first multiplier. So another one is sent to second multiplier. So here one is sent to first multiplier. The second bit is sent to another multiplier. So you consider the same signal. Here first bit is sent to the first multiplier, then second bit. So first bit, right? Next second bit is sent to second multiplier. Second multiplier. So here consider 0, 0. First bit, then it will send second bit to second multiplier. So therefore it is called what? 2 into 1 converter. Two serial bits are converted into parallel bits. So here it will generate, so this multiplier will generate the signal. And this multiplier will generate this signal. So this one is within phase. Within phase. Here we are changing the phase value for second binary phase shift keying method. So one or first binary phase shift keying part is what? Second binary shift keying part. So first binary phase shift keying method is within phase. The second one is out of phase. Therefore here we are adding 90-degree extra. 90-degree extra. Therefore it will go what? Out of phase. Out of phase. First one within phase. Second one is out of phase. So from these two we will generate signal. Two signal. Then these two signals are sent to uh, adder or a summation. The process is what? The summation. Sum. Then a summation or adder will take these two signal. Then it will generate final signal. So final generated signal. Final generated signal. So this is what hardware implementation of quadrature phase shift keying method. Here if you have any doubts you can ask. Take 2 bits at a time. Send 1 bit to first one, second bit to second phase shift keying method. First phase shift keying method is what? In phase. So for second one, oscillator will add 90-degree. So therefore, out of phase. Then add these two to get final signal. So if you have any doubts. Yes, we'll move to next concept. Next, consider one problem. Find the bandwidth for a signal transmitting at 12 MB per second for quadrature phase shift keying method. The value for D is 0. Find the bandwidth. How to find out bandwidth B? Bandwidth B. The given signal transmitting at 12. Given what? The S value. Sorry. The given S value, and you have to find out bandwidth. Here, in case of quadrature phase shift keying method, we are sending 2 bits at a time. So 2 bits at a time. 2 bits are represented by one signal element. Therefore, R value 2 divided by 1, so equal to 2. So R value 2, signal transmitting at, sorry, here they given N value, not S value. Bits per second means N, right? So N value they give 12 MB per second. 12 MB per second. So find out S value. S value, S that is equal to 12 divided by 2. So 6 MB watts. If they given in terms of watts means that indicates S. They given in terms of bits per second that indicates N. They given N value 12 MB per second into 1 divided by 2. So you will get what? 6 M watts. 6 M watts. So next you know formula for bandwidth. So what is the formula for bandwidth? So B that is equal to 1 plus D into S. So here D value they given 0. So therefore B equal to what? S. The bandwidth equal to S. Therefore 6 megahertz. 6 megahertz is the bandwidth. So be careful while considering the units. Signal means bits, N means bits, bandwidth means hertz. Signal means birds, N means bits, bandwidth means hertz. So this is about problem. Now we'll see the last concept, quadrature amplitude modulation. Quadrature amplitude modulation is the combination of amplitude shift keying method and phase shift keying method. So we discussed what amplitude, frequency, phase. Last one, quadrature amplitude shift keying method or modulation. So here we are using two things, amplitude shift keying method, phase shift keying method. So suppose if the exam get question related on what quadrature amplitude modulation, be careful. Quadrature phase shift keying method is different. Quadrature phase shift keying method is different. Quadrature amplitude modulation is different, or quadrature amplitude shift keying method is different. Quadrature amplitude shift keying method means how to consider quadrature means phase value, amplitude means amplitude value. So therefore you have to explain both amplitude shift keying method and phase shift keying method. Okay, explain these two concepts, amplitude shift keying method and phase shift keying method. So we'll see quadrature amplitude modulation, also called as QAM. So it's a one diagram that shows both phase and voltage value for a signal element, phase and amplitude value, because we are using phase and amplitude to represent signal element. So this is a one simple representation of phase and amplitude for a single signal element. So here this dot indicates signal element. This diagram is called as constellation diagram. So this diagram defines the amplitude and phase value for a signal element. Amplitude and phase value for signal element. So dot indicates what? Signal element. Now we'll see how quadrature amplitude modulation will use amplitude and phase value to represent digital data. So here we are using both amplitude and phase value. Be careful. We are using both amplitude and phase value. So suppose consider this one is this dot indicates signal element, means for 3 cycles represent what? 3 cycles represent 1 bit. Assume 3 cycles represent 1 bit. Here frequency is constant. So here the angle between x-axis and this point, that indicates the phase value for this signal element is particularly for what? One, first binary phase shifting method, in phase carrier signal. In phase carrier signal. So this is the phase value for the signal element. Signal element was considered here. We are using two amplitudes. Two amplitudes. So this one indicates voltage level. So year to year indicates what? The voltage level for the signal element. Amplitude of I component. So this indicates another voltage. Amplitude of Q component. So this is for quadrature carrier. In second binary phase shifting method. This is for what? In phase carrier. Means first binary phase shifting method. So phase value is measured by what? The angle between x-axis to what? This particular signal element. This particular signal element. So length means year to year indicates what? Voltage amplitude. So one voltage is 0, you need to consider. Another one is what? This voltage. This voltage you have to consider because we are using both the phase value and amplitude. So for in phase, how to consider this voltage? So year to year, 0 to something plus 10. Here 0 to 20. 0 to 20. The angle, this angle indicates what? The signal in phase signal phase value. So plus 90 you need to add for out of phase. Plus 92 you have how to add for what? Out of phase. So same concept you need to use. You need to use. So for one you need to calculate angle. To calculate angle, how to use this concept? Signal element, the angle between x-axis and this one. So that value in phase part. So for that angle, suppose if you add what? 90 degree, that indicates what? Out of phase value. So this is what the representation for quadrature amplitude modulation. Now we'll see different variations. So here amplitude shifting method and phase shifting method. So suppose consider I used 4 quadrature amplitude modulations. So means 4 signal elements. 4 signal elements. Here also 4 signal elements, but different quadrants. The same quadrants, different quadrants. Here the same quadrant. Here different quadrants. So 4 signal elements here we considered. So first consider this one. The phase value 0. Voltage also 0. Here the phase value 0. The voltage suppose consider 10. Here the phase value approximately 45 degree, means almost 45 degree for this signal element. Phase value 45 degree. So amplitude suppose here 10 volt. So here the phase value 90 degree. This signal element phase value 90 degree, and the amplitude 10 volts. Like that you have to use amplitude and the phase values in QAM method. Consider second one. 4 signal elements we are considered here to represent digital bits. The first one 45 degree, so amplitude 10. Here 45 degree, 45 sorry, yes, 45 degree, so minus 10 volts. Suppose consider here approximately minus 10, and here 45 degree minus 10, third quadrant. Here 45 degree, 45 degree, okay, 10, 4 quadrants. So here we consider here to here 45 degree, here approximately 55 degree, one approximately 35 degree, approximately 45 degree. So these are what phase values: 45, so 55, 35, 45. Then voltage you need to consider here: 5 5 volt, 10 volt, here 5 volt, 10 volt. So like that, consider 16 signal elements. 16 signal elements. The same concept you need to apply here also. But here the angles are varies, different quadrants. Different quadrants. This is about amplitude, sorry, quadrature amplitude modulation method.